Okay, so on page 20, number 94, it says, which of the following is not, so just be careful, that says not equivalent to this. Okay, so I notice that this has 4 terms, so I am going to group these first 2, and then I'm going to group the second 2. So let's look at the first 2. Okay, so I see that they have a GCF of x squared. If I take that out, I'll be left with x plus 2. Then if I look at the second grouping, remember, if your first term in that second group has a negative, we want to take out a negative. Okay, so I'm going to take out a negative 9, and that's going to leave me with x plus 2. Now, if we look at this is exactly the same as choice 1. But it wants to know which one is not equivalent, and these 2 are equivalent. So therefore, choice 1 can't be your answer. All right, now you know the next step in this process is to take your 2 GCFs, let's put them together in one set of parentheses, and x plus 2 in the other, okay? All right, so then if I look at this and I look at choice 3, I see that doesn't match. This says minus 2, but it's supposed to be a plus 2. So I do know that that is my answer. I'm going to keep going just to show you why the other ones are what they are. Okay, so now I do know also that this is dots, so I can keep going with that. So I'm going to factor that out to x plus 3, x minus 3, and then I'm going to bring down that x plus 2. Okay, so if you look at what I have here, that's the same as choice 4, and that's why choice 4 wouldn't be the answer. Now let's look at choice 2 for a minute. Okay, so choice 2, if we look at that, okay, so I've got x times x squared minus 9 plus 2 times x squared minus 9. Okay, you see that these both have the common factor of x squared minus 9. So what I'm going to do then is just bring the x plus 2 as the 2 GCFs in one set of parentheses, and then that common factor goes in here in the second set of parentheses. Now look at what we have here. That matches what I have here. It's just in a different order. Okay, so the x squared minus 9 is first, here it's second, but that doesn't matter because it's multiplication, and multiplication is commutative. So these 2 are equivalent, okay, which means that answer choice 2 couldn't be the answer, okay? And again, the answer for number 94 would be choice 3. Alrighty, so number 95. I already see that I've got 2 terms here separated by a minus sign. So if I look on the left and I look on the right, I see they both have a GCF of x to the 4th minus 16. So I'm going to take that out. Okay, so I'm going to make x to the 6th, y to the 4th minus 9. I'm going to take those 2 GCFs and put them in one set of parentheses. And then the x to the 4th minus 16 I'm going to put in the other parentheses. Okay, so again, because these are the same term, those came out and they are right here. And then I took this term and this term and put them together in one set of parentheses. Now, this is the difference of 2 perfect squares, and this is the difference of 2 perfect squares. So I'm going to keep going. Okay. All right. So I can break this up. Now remember, exponents are perfect squares if they are even, and we just cut them in half. So that's going to become x to the 3rd, y to the 2nd, and the square root of 9 is 3. And then I repeat again, x cubed y to the 2nd, but with a plus 3. Okay? All right. So now let me keep going because I've got the difference of 2 perfect squares right here. So I'm going to do the same thing. So that's going to be x squared plus 4 and x squared minus 4. Okay, now let's just stop, take a look at what this is asking. Which expression is equivalent? So let me just see if this is here, because if it's one of the answer choices, then I'm just done. Okay, x cubed, y squared minus 3. I've got that right here. And here's the plus 3. I got that right here. And then look, I've got x squared plus 4, which matches that. And I have x squared minus 4, which matches that. So bing, we are done. The answer is choice 4. Now, just FYI, technically, it didn't ask us because it doesn't say to completely factor. It just says which expression is equivalent. Do understand that this is dots, and we could turn this into x plus 2x minus 2, but it wasn't required because our answer is there. This is not dots because we don't have a difference. That is a sum of two perfect squares, and we can't factor that. Okay, so this term, and this term are completely factored. This one is not. Okay? All right, so it gives you this expression, x plus a and x plus b, and they're being multiplied, and it wants to know which one cannot be written as this x plus a and x plus b. So my thought process is, let me just multiply this out. So that gives me x squared. I'm going to multiply this out. That's going to give me bx. I'm going to multiply this out. That gives me ax. And lastly, I'm going to multiply those two, and that's going to give me ab. Okay, now these guys right here are not like terms because this is a b and this is an a, so I can't add them. I'm going to go up here and I'm going to look and I'm going to see if I see that, and I don't. I see x squared, and I see the ab. I see it here and here as well, okay? But I don't see this in either of these guys. So now what I think I'm going to do is I'm going to take each choice one at a time and see if I can get them to match what I have right here. All right, so let's look at choice 1. So if I distribute this, I get ax. If I distribute this, I get plus ab. Plus, and then now I get x squared, and here I get plus bx. Okay, so now if I look at what I just wrote right here, that is equivalent to what I have right here. Okay, but they want to know which one is not equivalent, so choice 1 can't be the answer. Choice 2 can't be the answer because what I have right here doesn't match what I have here. We can't add these. They both have x's, but a and a b, we can't add them. They're not like terms. Okay, so I'm thinking that's the answer. Let me keep going, and let's just do the same thing here and here that I did like in choice 1. So my x squared is going to stay the same. Now let me distribute that x through. I get plus ax plus bx plus ab. And that matches what I have down here in the box. Okay? And let's do the same thing with choice 4. That gives me x squared. That's a squared, by the way, sorry. And then here, that gives me plus ax. Then here, plus bx. And lastly, plus ab, which matches, again, what I have in the box. Okay, so the answer is choice 2. All right, so number 98 is very similar to the last question that we just did. So you can see again that we have a trinomial. We have one term, two terms, three terms, in this case separated by plus signs. So what we're going to do is, I notice that the first two factors both have, the first two terms I should say, both have the same factor. So I'm going to let A, you can pick any letter, just not X, be X plus 2. Okay, so then what I'm going to do is I'm going to replace this with A, and I'm going to replace this with A. And then we know that this is squared plus 4 plus 3. There we go. Okay, now let's look at what we have here. We have 1, 2, 3 terms. There's no GCF. Nothing goes into all three of these terms besides a 1. So then we know that if we have a trinomial with 3 terms, we're going to figure out what adds to 4 and multiplies to 3. Now we know what multiplies to 3. The only thing that multiplies to 3 is 3 and 1, right? And let's follow the rule. So the rule is if the last sign is positive, that means these guys will both be the same sign. And then we look here and we see that this sign is positive, which then means that both this 3 and this 1 are both going to be positive. So I'm going to repeat that one more time. Last sign tells you that the signs are going to be the same. This sign tells you what they're both going to be. So that's why I have a positive and a positive. Okay. All right, so then we know when we have a trinomial, we go open up 2 sets of parentheses. A squared is that first term there. So that's going to break down to A and A. And then we have plus 3 and plus 1. Okay, now that's not our answer because remember, we temporarily plugged in A here and here. So now we're going to take this A, which is X plus 2, and we are going to put it back in. So A is going to get replaced with X plus 2, and then we have a plus 3. Okay, and this other A is also going to get replaced with X plus 2, and then we have the plus 1. All right, now I'm looking at what I have right here, and I don't see that up here anywhere. So I'm going to keep going then with it. If it's not an answer choice, let me keep going. So I'm going to have X, 2 plus 3 is 5. And then over here, I'm going to have X, and 2 plus 1 is 3. Now let me see if that answer choice is there. So I'm looking for X plus 5 and an X plus 3. And I see that right there. That's choice 2. Okay, so your answer is choice 2. On page 21, number 99, it says which factorization is incorrect. So which one is wrong? I look at this and I say, ooh, that's dots. See, I have the difference, and these are both perfect squares. So if I take the square root of 4, I will get 2 and 2. If I take the square root of k squared, remember we take half of the exponent, and that would be k and k. And then the square root of 49, which is 7 and 7, and 1 plus and 1 minus. So that actually is correct. So, but they want to know which one is incorrect. So that can't be it. Okay, now let's look at choice 2. I don't really know any other way to do it than to, let's just distribute this times that. So let me just write this. So this is going to be choice 2, and that's going to give me A cubed. Then I'm going to multiply those two, and that's going to give me plus 2A squared B. Then I'm going to multiply this times this, and that's going to give me plus 4AB squared. Now I'm going to repeat that process, but I'm going to distribute the negative 2b through now. So I'm going to distribute that through. And that's going to give me negative 2a squared b. So I'm going to put that underneath this one because it's a like term. Negative 2a squared b. So you see that that's going to cancel out. Okay, then here I'm going to get a negative, right? Yes, negative 4. and then I'm going to have an a and then a b squared. So that's also going to cancel out. And then lastly, when I do those two, I'm going to get minus 8b cubed. Okay, so now if you look at what's left over, okay, all we have is a cubed, and then minus, that's a minus 8b cubed. And that does match what you have right here. So that's not incorrect, that is correct. So that's not the answer choice. All right, let's look at choice 3. Well, we can go about this a couple of ways. I think what I'm going to do is I am going to group these two terms here and group these two terms here, and I'm going to factor that. So let me put that down here. So when I group the first two terms, I can take out an m squared. And when I take an m squared out of the m cubed, I have m left over. And when I take an m squared out of the 3m, right, that's dividing 3m squared divided by m squared, that just leaves me with plus 3. Okay. Now these second terms right here, remember, if your first term has a negative, let's take out a negative. And I see that 4 and 12 have a common factor of 4. So I'm going to take out a negative 4. And then when I divide that, that's going to give me a positive m and a negative 3. Okay, now if I look at that, I have a problem. Because remember, when I group and group, what I have left here should be the same, and it's not the same. So which factorization is incorrect? It is this one. So your answer is choice 3. Okay, now, just FYI, let's look at choice 4. Because choice 4, we have got, how many terms do we have here? 1, 2, 3, 4, 5, 6 terms. And I see that my numbers, my coefficients here, I've got a 1, 5, 6. Then I've got another 1, 5, 6. So just to show you, I would group in threes. Okay, and let's try choice 4. So out of that first grouping, I can take out a t. I see that they all have a t. And then that leaves me with t squared plus 5t plus 6. And if I look at the second grouping, well, look at what I have here. This matches that. So then I don't want to change this at all. So if you don't want to change something, you still have to take a GCF out. Let's just take out a 1. Because if we take out a 1, that's going to leave that as t squared plus 5t plus 6. Okay, so now we take our two GCFs, put them in one set of parentheses, and then we take our t squared plus 5t plus 6, and we put it in another set of parentheses, just like that. Okay, so I'm going to look at this. I'm going to say, that's a trinomial. There's no GCF in here, so then I know that I'm going to do AM. So what multiplies to 6? 6 and 1 does, and so does 3 and 2. Okay, now let's follow the trick on this one, because this can be a little tricky. Our last sign is positive, which means these guys have to be the same sign. And this tells you what they're both going to be. So let's do this. If I put a plus and a plus here, would I, when I add, would I get 5? Well, no, I wouldn't. I would get 7, wouldn't I? All right, so let's go and look at the other option. If I have a positive 3 and a positive 2, when I add these two, right, because I have to add them, will I get 5? And yes, I will. When I multiply them, will I get a positive 6? Yes, I will. So then in that case, we are not going to use those, and we're going to use the plus 3 and the plus 2. So I'm going to bring this down, and then I've got t plus 3 and t plus 2. And you can see that this answer matches choice 4. Okay, but they want to know which one is incorrect. All right, so they want to know which of these 4 expressions can be rewritten correctly to form a true statement. True statement. Okay, so let's look at choice 1. Okay, now I see that I've got a 1, 2, 3. I've got a trinomial here, right? And 2 of those factors are the same. So remember, usually when that happens, what we'll do is we will temporarily replace that x plus 2 with a variable. Okay, so for choice 1, I would say a squared plus 2a minus 8. And I want to see, so I'm going to put a little question mark there, if that equals x plus 6 times x. So let's see what happens. Okay, well, I'm going to factor this. So I know I'm going to have a and a, and I'm picking two numbers that multiply to 8. So that would be 1 and 8, or 2 and 4. Okay, and now let's just follow the rule. The signs will be different, and the larger number will get a positive. So let's do that. Larger number is positive, larger number is positive. Okay, so looking at those, okay, let's just remember that we're doing a trinomial factorization. So what adds to 2 and multiplies to -8. So these here, what I probably should have done, hold the phone here for a minute, these would then be negative, wouldn't they? Silly me. This adds to a positive 2. This does not. This adds to positive 7. So then we know it's going to be a -2 and a positive 4. So -2, positive 4. Okay, and again, I'm trying to see if this equals x plus 6 times x. Okay, now remember, then we go ahead and we replace the a back with what we had originally designated it as being, which was the x plus 2, right? So this is going to be x plus 2, and then we have a -2 at the end. And then this is going to be x plus 2, and then we have a plus 4 at the end. Okay, and again, I want to see if that will equal, that's a question mark, x plus 6 times x. Alrighty, well, the first parentheses, those cancel out, so I just have an x, and here I have x plus 6. Look at that. So it does equal the right-hand side. So your answer is choice 1. Alrighty, so number 101 on page 21. So I think I'm looking at this, I see 4 terms, so I'm going to group the first 2, and I'm going to group the second 2 and take out a GCF. Well, 5 and 6, there's nothing that goes into them besides a 1, but I do see that they both have x's. This has 3 of them, and this has 2 of them, so I can take 2 away from each of those. So I'm going to pull out an x squared, and that would leave me with 5x minus 6y. All right, now let's look at the second 2 terms here. Okay, I see a negative first, right? See, there's that negative, so I'm definitely going to pull out a negative here. And what goes into 45 and 54? That would be a 9. Also, this has 2 y's, and this has 3, so I can pull out 2 from each of those. Okay, so I'll repeat. Because that 45 is negative, I'm going to pull out a negative. Now I'm looking at 45 and 54, and 9 goes into both of them. Then I see that they both have y's, and I can pull out 2 from each of those. Okay, now let's divide out. So I'm going to do 9 into 45, okay, and I know that that is 5, and I have an x left over. The y's cancel out. Then just be a little careful here. I have a negative divided into a positive. So that's going to give me a negative. And 9 into 54 is 6. And I have y cubed, so I'm actually going to have a y left over. All right, well, this looks great because what I have in parentheses here and here match. So I'm going to keep going. So I'm going to bring down those GCFs, x squared and the minus 9y squared, and they go in one set of parentheses together, right? And then I bring down the repeated term. Okay. All right, now I'm going to stop because I went too far now, didn't I? Which is okay, but I didn't need to go that far because let's look at what I have right here. Do you see that that matches choice 4? Okay, so word to the wise, learn from Miss Carter. Read the multiple choice, okay? Because they're not asking you, it says which expression is equivalent. It's not saying for you to factor this completely, which is what I was starting to do, okay? So basically, I could have stopped right here, looked at my answer choices and said, ooh, this one matches, okay? All right, so then we are done with that answer choice, with that question, but you know what? I'm going to keep going. I see that this left one right here is dots. So just to show you completed, that would be x minus 3y and an x plus 3y. And remember, those can be in any order. So I could have, instead of the minus 3y here, I could have the plus here and the minus here. Okay, that doesn't matter. And then 5x minus 6y. Now again, that wasn't what the answer, what the question was looking for. But if it was an open-ended question on your test, you would have to know how to do this. All right, number 102 on page 21, the last question. So Mrs. Paris incorrectly factored 100 minus 25x squared. And you can see over there on the right, this is what she got. So we have to explain her mistake. Well, when I look at 125, I try to think of money, and I say, ooh, well, I've got 4 quarters and $1, don't I? So I can take out a GCF here. And when I do that, I'm going to get 4 minus x squared. Okay? We're going to explain this in just a moment. So, and it says, and determine the correct factorization. So I factored it, but please keep in mind that this is dots, and we can keep going with that. Okay? So I'm going to keep that 25, and then this will be 2 minus x and 2 plus x. So that is the correct factorization, by the way. Now, it says to explain her mistake. Remember, explain means you always have to write a sentence. Okay, you have to explain in words. So what did she not do? So Mrs. Paris, shame on Mrs. Paris, she forgot to factor out the GCF, right? She forgot to factor out the GCF, and let's state what it is, of 25. Okay, so this is the explanation, and this is your correct factorization. Okay?